Hello everyone, in this lecture we're going to talk about modular arithmetic. So what is modular arithmetic? So modular or mod is an operation that tells you what remains after dividing one number by another. So modular or mod, as we're going to use it, is an operation that tells what remains after dividing one number by another number. Now that is kind of the intuitive idea behind a modular arithmetic. Now for a more formal definitions, this is what we're going to have. So for this definitions, we say that A is congruent to B modulo n, and we denote or we write A congruent, so there's 3 lines, to B mod n if A and B have the same remainder when divided by n. So why do we even need to care about this type of operations? So think about this scenario. What if the hour that you watch this video is at 1 o'clock? And you're going to ask the questions, what time is it in 2 hours? It makes very easy sense just to do additions, right? So 1 plus 2 is going to be 3 o'clock. Now what about 5 hours, right? So after 5 hours, you can do simple additions that 1 plus 5 is 6 o'clock. Now what time is it in 15 hours? So 1 going to plus 15 is going to equal to 16. So what it means to have a 16 o'clock. So 16 is the same as 4 with respect to the 12-hour clock system. So let's write down that simple example first. So currently, let's say this is going to be 1 o'clock. And you want to know what time is it in 2 hours. So the answer is 3 o'clock. Now what about after 5 hours? What you're going to have is going to be 1 plus 5 is going to be 6 or 6 o'clock. What about 15 hours? So 1 plus 15 is going to be 16. But 16 o'clock here means the same thing as 4 o'clock with respect to a 12-hour clock system. So with respect to, so WRT means with respect to a 12-hour clock. And you can do the same calculations when you ask the questions such as, what time is it in 100 hours? So it's not going to be 101 o'clock, it's going to be 5 o'clock. So how could I do that, right, using the modular arithmetic? So 101 is A times 12 hours spent plus 5 hours. So that means that in about 100 hours, you're going to go to 5 o'clock. So what you do is that, let's say you ask the question, what time is it in 100 hours? Is it going to be 101 o'clock? Right. So the explanation is that when you take 101, you divide it by 12, you're going to get some integer quotients and a remainder. And that remainder is going to be the result that you're looking for, which is 5 o'clock. So 101, you divide it by 12, is going to give you 8 with remainder 5. Or you can think of this as follow. So 101 minus 8 times 12 is going to give you 5 for the remainder. The 101 is equivalent to the 5 o'clock in the 12-hour clock system. So this means 101 is equivalent to 5 o'clock in 12-hour clock system. So when you look at the 12-hour clock system, you're going to have 1 o'clock, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 o'clock, and then to 12 o'clock. Now you go back to 0 because the remainder of 12 divided 12 is going to be 0. Then the hour 13 13 is going to be 13 divided by 12, give you a remainder of 1. That means you go back to 1 o'clock. Now for the 14 hours, so 14 divided by 12, the remainder is 2, so that's going to be 2 o'clock. The 15 divided by 12, the remainder is 3, so you're going to have 3 o'clock, so on and so forth, until you feel whatever hours that you want to calculate. In terms of real-world applications, let's take a look at the day of the week. So currently, I'm recording video on Thursday, June 18. All right, so today is Thursday, June 18 in 2026. And this is the 4th day of the week, or day 4 of the week. So this is day 4. Now you can ask the questions that what day or what day number in 2 days. So 4 plus 2 is going to be 6, or day 6, and that is going to be a Saturday. And you can ask the similar questions. What day or day number in 3 days? And that day number is day 7, or is going to be a Sunday. And the day that we are considering are equivalent of to addition or subtractions of a multiple of 7, because we have 7 days in the week. So that's a very important conclusions I want to draw here, that days are equivalent up to addition, the subtraction of a multiple of 7. And the value of n, which is the denominator in the modular arithmetic, is going to be 7 in this case. Now, if you go back to the example earlier, the denominators that we're going to use for the modular arithmetic is going to be n equal to 12. So we can draw a similar conclusions here for this example. That is, so times are equivalent up to addition and subtraction of a multiple of 12, because we are considering the case of 12-hour clock system. So with this conclusions in mind, you're going to ask the questions, what day is it in a year from now? So let's consider 365 day without the leap year. So what day number in 365 days? So this is day 4 of the week, and what you're going to do is you take 4 plus 365 is going to be equal to 369, and what you do is that you're going to use this number 369 divided by 7. So take 369 divided by 7, you get the integer quotient of 52 with the remainder of 5. So that means that a year from now, June 18, 2027 is on a Friday. Okay, so again, how could I get the remainder of 5? You can carry out the division and you will see the remainder is going to be 5. And again, 5 is going to be a Friday in this particular scenario. Another way to look at the remainder is that whatever you got for the 52, right, which is the integer quotient, take that 52, multiply with 7, and you do a simple subtractions to get the remainder of 5. Or I can actually go here and do the calculations. That is going to take 369 minus 52 times 7, and if you carry out calculations correctly, you're going to get 5 for the answer, and this is going to be the remainder that you're looking for. So that's the 2 real-world applications I want to bring up in terms of modular arithmetic. Now you want to go back and formalize all of this information in terms of mathematical notations. So for this example, 369 is going to be congruent to 5 mod 7. This means that when you carry out the division of 369 by 7, you're going to get the remainder of 5. Similarly, when you go back to the last example, and you take 101 divided by 12, you get 8 for the integer quotient with the remainder of 5. The mathematical notations in terms of the modular of arithmetic is going to be 101 congruent to 5 mod 12. Now, in the next example, I could ask you to fill out the information in the following table. That is, I want to determine what each number is congruent to mod 4. So let's consider the following example. I'm going to set up the table here. So I have 10 different numbers here, and I want to determine what each number is congruent to mod 4. So what you do for each number is take that number, divide it by 4, and look for the remainder. So 0 divided by 4 is going to be 0. There's no remainder, and it's going to be equal to 0. Now, 1 divided by 4, you're not going to get the integer from the divisions of 1 over 4, so the remainder of this is going to be 1. 2 divided by 4, you're not going to get the integer quotients from this calculation, so the remainder is 2. Similarly, the remainder of 3 over 4 is going to be 3. So 4 divided by 4 is going to be equal to 1. The remainder is equal to 0. 5 divided by 4 is equal to 1 for the integer quotient, and the remainder is 1. 6 divided by 4 is equal to 1 for the integer quotient, and the remainder is going to be 2. Right? You can carry out the simple calculations if you want to. So 4, and this is 6. So 4 go into 6, you get 1 times. So 1 times 4 is 4. You do subtraction here to get the result of the remainder. So 6 minus 4 is 2, so you get 2 here. So 6 is congruent to 2 mod 4. Now for 7 divided by 4, you get 1 for the integer quotients, and the remainder is going to be 3. 8 divided by 4, you get 2. There's no remainder, or remainder is 0. 9 divided by 4, you get 2 for the integer quotient, and the remainder is equal to 1. Next, 10 divided by 4. So 10 divided by 4 gives you 2 for integer quotients, and the remainder is going to be 2. So in the next example, I want to determine what each number is equivalent to for the specific modulus n. So here, 426 congruent to what number in mod 12? Right, so what it means is that when I take the number 426 divided by 12, what is the remainder of this? So 426 divided by 12, what you're going to get is 35 for integer quotient with the remainder 6. Again, how would you get the remainder 6? You can do a simple calculations as follow. So what you do is you take the original number 426, subtract 35, which is the integer quotient, multiply with 12, and you should get 6 for the answer. And therefore, the answer is going to be 426 congruent to 6 mod 12. Now the example that we can do here is that I want to get 6,123 congruent to what number in mod 9. So take 6,123 divided by 9 is equivalent to 680 with remainder 3. Or you can do 6,123 minus 680 times 9, and you get 3 for the answer, or this is going to be the remainder that you're looking for. Therefore, 6,123 is congruent to 3 mod 9. So what happened when you have a negative number? So negative a congruent to what number in mod 5? So for negative number, you're going to carry out the similar calculations. That means you're going to take negative a divided by 5, and the integer quotient is going to be negative 1. So negative a divided by 5, you get negative 1 with remainder 2. So how do I get this? All right. So negative 8 minus negative 1 times 5, or this is negative a plus 5. So the result is negative 3. What you want for the remainder is either 0 or positive number. Here we got a negative number, and to get a non-negative number, what you do is keep adding 5 until you get either 0 or positive. Why adding 5? Because we are working with modulus 5. So from here, you're going to keep adding 5, so 5 plus negative 3 gives you positive 2, and this is the positive number that you're looking for. Therefore, the remainder of this calculation is 2, and thus you can write negative 8 is congruent to 2 mod 5. So let's consider another example with a negative number. So the example is that I have negative 20. It's congruent to what number in mod 11? So you take negative 20 divided by 11 is equal to negative 1 with remainder of 2. So how do I get that? So now you take negative 20 minus the integer quotient here, which is negative 1, times 11, which is the modulus. You got negative 20 plus 11. It's going to give you negative 9. Now you need to keep adding 11 because we are working with modulus 11 in order to arrive at either 0 or positive remainder. So here I'm going to continue adding 11. So negative 9 plus 11 give you 2. Therefore, that is the remainder of this calculation. Thus you can write negative 20 is congruent to 2 mod 11.